So these applied problems using area formulas can be a little bit complicated. And again, sometimes I find the drawings they give you in the textbook make it seem more complicated. So let's look at what this one says. It says a rectangular reflecting pool in a park is 20 feet wide and 40 feet long. So I know we have the drawing here, but I'm going to just draw it. So we have a rectangular pool that is, I can't even draw a rectangle. There we go. Boom, there we go. Okay, is 20 feet wide and 40 feet long. It doesn't matter what goes where. So let's go 20 feet wide and 40 feet long. The gardener, maybe if we write these on the inside, it'll make more sense. Let's go 20 by 40. The gardener wants to plant a strip of grass of uniform width around the edge of the pool. So we're wanting to put this grass strip all the way around the pool. And it wants it to be uniform. And we have enough seed to cover 700 square feet. So we have enough seed. So as soon as you see feet squared, you know you're talking about area. So we know that we have an area of 700 that we can seed. And so what we want to do is come up with a formula that'll involve the area of this width of grass around the outside. So we don't know the uniform width, so let's call it X. That's what the textbook's done. So if it's X across here, it would be X across here. If it's X across here, it'd be X across here. And so all of these corners are a width of X. If I had drawn it uniform. Okay, and what we're trying to do is come up with a formula for this outer edge. So what I like to do is look at it as a big rectangle, take away a little rectangle. So you've got the area of the grass is going to equal the area of the whole outer rectangle, take away the area of the pool. Okay, so the area of the whole thing, taking away the area of the pool. So let's see if we can come up with an equation for the area of the whole. Well, the area of the whole is going to be this whole length here. So it's going to be the 20, and then it's got an x and an x. So this whole length would be 20 plus 2 x's. So that would be the, whatever we're calling that, the width. The length would be 40, and then an x and an x. So this whole length here would be 40 plus the 2 x's. And then the inner pool, or the pool itself, is 40 by 20. So writing an equation for that, we've got the area of the grass is going to equal the area of the whole. So this 20 plus 2x times 40 plus 2x. Take away the area of the pool, which is just 40 by 20. This is going to be our function. And we know that the area of the grass is 700. So what we have to figure out now is, how do we solve this? Well, we're obviously not going to solve algebraically because we're not going to be able to isolate all these x's. So let's simplify. Let's multiply through. We've got 700 equals 20 times 40 is 800. 20 times 2x is 40x. 2x times 40 is 80x. And 2x times 2x is 4x squared minus 40 times 20, which is 800. I'm going to come up with this quadratic equation, so I'm going to make it equal to 0. I'm going to subtract 700, and I'm going to collect like terms. So 0 equals 800 minus 70. Well, let's do it in descending order. So let's go 4x squared first. Then we've got 40x plus 80x is 120x. And then we've got 800 minus 700. First thing I would do is try to make this simpler. So I'm going to divide both sides by 4. Again, or you could just greatest common factor the 4 out if you're nervous, but I know I'm solving for x, so I can. So I end up with x squared plus 30x minus 700 divided by 4 is 175. And again, I could try to factor this. I could look for two numbers that multiply to give me 175 and add to give me 30, but I'm way too lazy to do that. So my options at this point are to plug it into the quadratic formula or to complete the square. Again, entirely up to you what you want to do. If you use the quadratic formula, you've got A, you've got B, you've got C, and then you're just plugging it in. This one says how wide should the grass strip be. It doesn't say that I'm going to be able to, I just lost my words. It doesn't say that I'm allowed to answer to the nearest tenth. Yeah, well, so the last one we use quadratic formula, so let's do the complete square. Let's do quadratic formula. So to do the quadratic formula, we're going to pull off A is 1, B is 30, and C is negative 175. I really want to complete the square, but I feel like I should switch it up. So, quadratic formula, negative b plus or minus b squared minus 4ac all over 2a. All right, plugging in b, we've got negative 30 plus or minus 30 squared minus 4 times 1 times negative 175 all over 2 times 1. Plugging this in, we're going to plug in that discriminant. So we've got 30 squared, and we're taking away 4 times 1 times negative 175, which is 1600, all divided by 2. So I've got two solutions, x equals negative 30 plus or minus. Now, square root of 1600 is 40 divided by 2. So we've got two answers. X is equal to negative 30 plus 40, all divided by 2, and x is equal to negative 30 minus 40, all divided by 2. This one ends up with 10 divided by 2, which is 5. This one ends up with negative 70 divided by 2, which is negative, wait a minute, negative 30 minus 40 divided by 2, negative 35. Okay, so these are my two solutions. This one is negative. I'm looking for a width of a grass strip. So obviously I'm going to have to reject this solution. And I know that x is 5. And then we want to double check if that makes sense. So if we go back up here, it says the gardener wants to plant a strip of grass with a uniform width. How wide should the grass be? So that's my x. The x was the width of the grass. Therefore, the grass should be 5 feet wide. Now, as soon as I got these nice answers, I realized I could have factored. I start getting lazy with factoring as soon as you have these other methods to solve. But when you get this perfect square, like radical, or yeah, perfect square discriminant, you know that you could have factored this. So this question was factorable. This question we could use the quadratic formula. And again, this question could have been done using completing the square. Just because I feel like I should, I'm going to complete the square. You can totally stop this video if you want. But we've got x squared plus 30x. You take half that middle term and square it. So 15 squared is 225. Subtract 225. We've got that minus 175 on the end. This is my perfect square, which factors to x plus 15, all squared. This is minus 400. Then we're going to move the 400 to the other side. Then you're going to take the square root, plus or minus. And then we'll notice that 400 is a perfect square, which factor simplifies to plus or minus 20. So then I'm going to subtract that 15. And those are my answers. X is equal to negative 15 plus 20, which is the 5, or x is equal to negative 15 minus 20, which is my negative 35. So up to you. I don't know which one you find easier. I enjoy completing the square, but the quadratic formula, I mean, it is just plug and play. You plug in the numbers, it comes out with the answer. This takes a little bit more math to get through it. But try the questions in the textbook that are related to area.